Example 7. An underground conical tank standing at its vertex is being filled with water at the rate of 18 pi feet cubic feet per minute. If the tank has a height of 30 feet and a radius of 15 feet, how fast is the water level rising when the water is 12 feet deep? So let's draw a picture of a cone real quick, right? It's an upside down cone, okay? And we know the radius is 15 and the whole height of the tank is 30 feet. Now we want to know how fast, right? So how fast is the water level rising? So how fast is the H is going up while the when the water is 12 feet deep, okay, at this moment. So a couple of things we know. Okay, first of all, dVdt, the volume is changing at 18 pi, is filling it up, so it's positive. And we want to know height at 12, what happened dHdt, how fast is the height changes when the height is at 12 feet. Okay, now we know the volume. Okay, it's the volume for a cone is 1/3 pi r squared h. Now the most important thing, now the problem with this equation is if you take the implicit differentiation, you have a dVdt, you have a drdt and dHdt. That's way too many variables because we only know dVdt and we're looking for drdt. We're not looking for dHdt. I'm sorry, we're looking for dHdt, but we're not looking for drdt at all. So the goal is try to get rid of one of the variables. Otherwise, you're going to have three different variables. So now the hint is this: they say the height is what. So the relationship between height and radius is what height is what double. If you look, right, and the cone is 30 feet. The height is 30, radius is 15. So h equal to 2r. So r equal to h over 2. Now, once you have the relationship, that's the key. We plug in this r in here into the equation where r squared is. So if you do that, now we have v equal to 1/3 pi. Instead of r, we have h over 2 squared times h. Now the equation is in terms of v and h only. We simplify that. So this is the equation we'll be taking the derivative of. Well, actually, this one after we simplify. So once we got to this point, then dv dt equal to that's constant. So derivative of h cubed is 3h squared. Then 3 to the front, so pi over 4 h squared and dh dt. Remember, we're solving for dh dt. We know h, we know dv dt. So once we have all the information, you solve for dh dt. Then our dh dt will be half feet per minute.